For your Unit 6 coursework, you're going to be looking at the voltage discharge of a capacitor. You're asked to determine whether the manufacturer's rating of the capacitor is correct. And you're going to be using this equation, V equals V0 e to the minus t over RC. You'll have seen this in lessons. Now this is the voltage at any time equals the initial voltage times this bit here. And this bit is e to the power of minus t. It's minus because it's decaying, so it's reducing. T is the time, and it's divided by RC. Now RC is also known as the time constant. And this is a very important feature for your circuit. Remember, it's denoted by the funny wiggly T called tau, and it is the resistance, the load resistor that you're discharging through, multiplied by the capacitance of your capacitor. And these two things multiplied together determine how long it's going to take your capacitor to discharge. Now, again, this is your coursework, so you're going to need to look some stuff up, but there is a particular percentage of your capacitor, so a particular amount of charge or voltage that will be left after one time constant, and that's a good thing to reference in your coursework. So I'll leave you to look that up. The purpose of this video is to work through the maths. You're asked to process the data that you'll take to get a straight line and to determine a constant. In your coursework, you are given that V equals some constant e to the minus t times another constant. I can't remember if it's divided by or times. We'll say it's divided by. So in the Unit 4 formula that you are given is Q equals Q0 e to the minus t over RC. Now Q is the amount of charge at any time, and that equals the initial charge times exactly the same thing. And from the lessons, you will have learnt, and you can reference, that voltage discharges in exactly the same way. So the way that charge changes and the way that voltage change over time are the same equation, just with different, one you've got Q equals Q0, and here you've got V equals V0. So you're going to start with the Unit 4 formula, and you're going to say that Q equals Q0 e to the minus t over RC. You're going to then say, well, you can use that formula for voltage as well, as you have been taught in lessons. Now we get into the processing bit. Now E is the natural number, and we can use it as a base for logs. I won't go into the details of logs here. I might upload a separate video actually, because it is interesting. So instead of doing logs to base 10 or logs to base 3 or logs to base 2, which you've done in your C2, we're going to take logs to base E, and they are known as the natural log, which is called ln. And you will see on your calculator that there is a ln button, and above it you'll see it's got E with a little box. So you undo the ln of something by doing E to the power of it. So we've got our V equals V0 e to the minus t over RC. Now we get into the important bit. How do we get a straight line? I'm going to leave you to work out what you need to measure to get the graph that you need. That's part of your coursework. But we're going to take natural logs of both sides. Ln V equals ln all of the other side, e to the minus t over RC. And so we get ln V equals, and the same log laws apply, whether it's lns or logs, you've got the same log laws. You've got ln V0 plus ln e to the minus t over RC. Again, we've got lovely log laws here, so we could take this power down to the front, and we get ln V equals ln V0 minus t over RC ln E. Right, you're all aware of the fact that the log to base 10 of 10 equals 1, because 10 to the power of 1 equals 10. So the ln of E is the log to base E of E. That is also going to equal 1 because e to the power of 1 just equals e. So that makes life a bit easier. If you remember, we had v, ln v equals ln v0 minus t over rc ln e. And that now becomes just ln v0 minus t over rc because this bit equals 1. So how is this giving us a straight line? We've got ln v equals ln v0 minus t over rc. Let's write it the other way round, and I think all will become clear. I'm also going to write things a bit more clearly on this side. I'm going to say that instead of minus t over rc, I'm going to write it separately. I'm going to say that's minus 1 over rc times t, and that's plus ln v0. Now, if I write the equation of a straight line, y equals mx plus c underneath, hopefully the penny is starting to drop. If we plot time on the x-axis and the ln of v0 on the y-axis, you can see that the gradient will give you minus 1 over rc, which is minus 1 over the time constant, and the intercept will be the ln of v0. And so this is what you need to show in your coursework, is how you're going to use the data that you will take. So on the next slide, I will run through it more succinctly. So pretty much what you need to be able to demonstrate, to manipulate your data to get your straight line for your coursework. So starting with Q equals Q0, e to the minus t over rc. From the formula sheets, you can say that you can also use that for voltage, as you've been taught in class. You're going to take the natural logs of both sides, and you're going to end up with ln v0, and we'll just apply our log laws straight away. You can do this, minus t over rc ln e. You don't even need to put the ln e if you don't want to. You can go straight to that stage, depends on how confident you are. Write that round the other way. You'll say that's minus 1 over rc times time plus ln v0, and that's ln v on this side, and we've got the equation of a line, which is y equals mx plus c. So if you plot time on the x-axis and the natural log of the voltage on the y-axis, you will be able to use the gradient here to find 1 over the time constant, 1 over rc, and you will be able to use the intercept, if you wanted to find the natural log of the initial voltage. So you're going to have to do the rest of it yourself for your coursework, working out what you're going to measure, how you're going to measure it, how you're going to design the circuit. But I am allowed to take you through the maths, and this is counted as showing appropriate physics within your coursework to talk about how you've taken the data, the formula that you've been given in your formula sheet, and actually turned them into something that you can use a graph to help you answer the question that you have been set. And remember, that question is to determine the capacitance, this bit here, the capacitance of a capacitor that you've been given, and to see whether the manufacturer's rating of that capacitor is correct.